Ever wonder how a jet engine works? It's not just magic. It's a fascinating blend of science and engineering that keeps planes soaring through the sky. Here's the surprising part. While it might look complicated, the basic idea is actually quite simple. Think of a jet engine as a powerful air pump. Imagine you're blowing up a balloon. When you blow air into it, the balloon expands. In a jet engine, air is sucked in through the front, compressed, mixed with fuel, and then ignited. This rapid expansion of hot gases pushes the plane forward. Let's break that down step by step. First, air enters through the engine's front, called the intake. It's like a big mouth, gobbling up air as the aircraft speeds down the runway. Once inside, the air gets compressed. Picture squeezing a sponge. You push the air into a smaller space, making it denser and ready to burn. Next, we mix in fuel. This is where the magic happens. The compressed air is combined with jet fuel, similar to adding kindling to a fire. When this mixture ignites in the combustion chamber, it creates a massive explosion of gas. And here's the cool part. That explosion doesn't just make noise. It forces the hot gases out the back of the engine at incredible speeds, which propels the plane forward. Just like how a balloon zips through the air when you let go of it. So what powers a jet engine? It's all about sucking in air, compressing it, mixing it with fuel, and igniting that mixture to create thrust. Understanding this helps demystify the powerful engines that keep us flying safely in the sky. At its core, a jet engine uses a principle called thrust. Imagine blowing up a balloon and then letting it go. The air rushes out one end, propelling the balloon in the opposite direction. That's similar to how jet engines work, pushing air backwards to move the plane forward. Here's how it all comes together. Jet engines take in air through huge front fans. This air is compressed, mixed with fuel, and ignited in the combustion chamber. When that fuel burns, it creates a high-speed stream of hot gases. These gases are then expelled out the back of the engine. And here's the surprising part. This rapid expulsion of gases generates thrust, which is what propels the aircraft forward. Just like the balloon, the jet engine pushes air out one end, and in response, the plane moves in the opposite direction. Think of it like a swimmer pushing against the water to move forward. The harder they push, the faster they go. In the same way, the more air a jet engine can push out, the greater the thrust and speed of the aircraft. Now you might be thinking, isn't that a bit basic? But understanding this simple principle is crucial. Without thrust, an airplane wouldn't take off, fly, or land. So next time you board a flight, remember the powerful force of thrust at play. It's about the science of moving air. And that's how jet propulsion works. Now let's break down the jet engine into 4 key stages: intake, compression, combustion, and exhaust. First up is the intake. Picture this like a big vacuum cleaner. As the aircraft moves forward, air rushes into the engine through the intake. This is the first step in powering the jet. Next comes compression. Once that air is inside, it gets squeezed down by a series of fan blades and compressors. Imagine squeezing a sponge filled with water. As you press, the water becomes more concentrated. That's what happens to the air. By the time it's compressed, it's incredibly dense, packed with energy for the next stage. And here's the surprising part. As the air gets compressed, it heats up. This is where the magic happens. The hot, dense air then moves into the combustion chamber, where fuel is injected. This stage is like lighting a fire in a cozy fireplace. The fuel ignites, and the explosion pushes the air out with tremendous force. Finally, we reach the exhaust stage. The fast-moving hot gases exit the engine through the exhaust nozzle, creating thrust. It's like letting the air out of a balloon, but with much more power. This jet of gas propels the plane forward, allowing it to soar through the sky. So, to recap, the 4 key stages of a jet engine are intake, compression, combustion, and exhaust. Each stage plays a crucial role in keeping that airplane flying smoothly and safely. And remember, behind every flight you take is this incredible dance of engineering and physics. Stick around to learn even more about jet engines. Now that we have our compressed air, the next step is combustion, where the magic really happens. Picture this. You've got a tightly packed balloon filled with air. If you squeeze it, the pressure builds up, and if you poke a hole in it, the air rushes out fast. That's similar to what happens in a jet engine, but even more dramatic. When the highly compressed air enters the combustion chamber, it mixes with fuel, Just like adding lighter fluid to a grill, the fuel is injected in a fine mist, creating a perfect blend for combustion. Then, a spark ignites this mixture, creating a rapid and controlled explosion. Think of it like lighting a firecracker. That little pop releases a burst of energy, pushing the exhaust gases out at high speed. Here's the surprising part. That explosion doesn't just make noise, it generates a massive amount of pressure. This high-pressure explosion forces the exhaust gases out through the back of the engine, similar to how a balloon shoots out air when you let it go. As those gases exit, they push the aircraft forward, creating what we call thrust. So, to summarize, the ignition of fuel in the combustion chamber transforms the compressed air and fuel mixture into an energetic explosion, producing the thrust that propels the aircraft. It's a perfect dance of physics and engineering, working together to lift you into the sky. And remember, every step from compression to combustion is meticulously designed to ensure safety and efficiency. Wouldn't you say that's incredible? Many people believe that jet engines are prone to failure, but in reality, they are incredibly safe. Think of it this way. A jet engine is designed with multiple layers of safety, much like a well-constructed bridge. If one part were to fail, there are backups in place to keep the entire system functioning smoothly. Each engine undergoes rigorous testing before it even sees the inside of an airplane. Manufacturers run simulations that put the engines through extreme conditions, far worse than what they'd ever face in the skies. This means they can catch potential problems before they become real issues. It's like a car mechanic checking every bolt and screw under the hood before you drive off the lot. And here's the surprising part. Jet engines are built to fly effectively even if one engine fails. Imagine driving a car that can keep going smoothly even if one wheel loses pressure. Most commercial jets are designed with redundancy, meaning they can operate on one engine without compromising safety. Pilots train extensively for these scenarios, so if an engine does have an issue, they know exactly what to do. In fact, engine failures are incredibly rare, occurring in a tiny fraction of flights. The aviation industry is always learning, improving, and implementing better technologies. This commitment to safety is what makes flying one of the safest modes of transportation available today. So, while it's perfectly natural to worry about engine failures, rest assured that jet engines are among the safest and most reliable machines humans have ever built. Next time you're in the air, you can relax knowing that the engine is working hard and that it's designed to keep you safe, no matter what. So, how does a jet engine actually work? It's all about transforming fuel into thrust through a well-orchestrated series of steps. Imagine a giant vacuum cleaner. It sucks in air, compresses it, mixes it with fuel, ignites it, and then blasts it out the back, generating forward motion. First, the large fan at the front pulls in a massive amount of air, much like the way a fan pulls in breeze on a warm day. This air doesn't just sit, it gets squeezed tightly in the compressor. Think of it as packing a suitcase. The more you compress, the more energy you can store. Once the air is compressed, it's mixed with fuel in the combustion chamber. Here's the surprising part. The fuel is ignited, creating a high-energy explosion that pushes the air out at high speed. This is where the magic happens. The rapid expulsion of gases propels the aircraft forward, thanks to Newton's third law. For every action, there is an equal and opposite reaction. The design of these engines is incredibly reliable. In fact, they undergo rigorous testing and maintenance to ensure peak performance. Most importantly, these engines are built with multiple backup systems, making failures extremely rare, and pilots are highly trained to handle any situation that might arise. Next time you fly, you can rest easy, knowing that powerful engineering is at work to keep you safe in the skies. But their reliable operation is the result of decades of innovation and safety standards. If you're curious to learn more about flying, don't forget to subscribe. Vocabulary: fuel, thrust, compressor, combustion.